and the tangent line segment is going to be 24. All right. Here we go. Here we go. Here we go. Here we go. Same old, same old. I think we're going to do the Pythagorean theorem. You know it's a right angle right here. So let's use the Pythagorean theorem. A little tricky, folks. This is a little tricky. Here, T-R-I-C-K-Y, tricky. All right, a squared. Let's see, x squared plus b squared. I gotta make sure I identify the two legs of the triangle, the right triangle. There's a squared, b squared. Those are the legs. A squared plus b squared equals. Now, if you're gonna make a mistake, it's gonna be right here. The total distance of this hypotenuse, it's here, from here to here. You add these two pieces together, it's going to be x plus 16. A lot of people like to put 16x. They think it's multiplication between these two, which is just horribly, horribly wrong. Add these two distances together, and that's going to be your hypotenuse. X plus 16 squared. A squared plus b squared equals c squared. A squared plus b squared equals c squared. All right. I need to get my calculator off my phone. I think 24 times 24 is 576. I don't know why that number's jumping out at me. 24 times 24. Yep. Cool. Plus 576 equals. Here's another place that you can make a mistake. It's a mistake that Algebra 1 students make back in their freshman year or their 8th grade year. They write this. They write x squared plus 256. X squared plus 256. That's it right there. Right there. That's it. No. Garbage. Straight up garbage. That's trash. X squared plus 576 equals. You need to write this x plus 16 two times. And you need to double distribute. That's the correct way to do this problem. So double distribute. Let me get a different color. Here we go. That's going to be x squared. X times 16, that's plus 16x. That's another plus 16x. Forgot the x right there. And 16 times 16 is that 256 that I just punched out in the calculator. On this side, we've got x squared plus 576. And I know you're probably looking at this thinking, oh shoot, we're going to have to factor. It's an x squared term. Well, maybe not. Because I'm looking at this equation, and yeah, you can combine like terms. That's probably your very first step. It's mine. I like to combine those like terms. Plus 32x plus 256. But if you take a look, you have an x squared on both sides. Which means, if you subtract x squared on both sides, they gone. They're out of here. 576 equals 32x plus 256. It gets a heck of a lot easier. Super, super easy. Okay, subtract 256 on both sides. 32x comes down, comes down, 0, 2, 3, 312. Oh, jeez. Does it get any sweeter than that? Because you divide by 32 on both sides, and x equals 10. X equals 10, folks. So this radius up here is 10 units long. That's also 10. So the entire distance is going to be that 10 plus 16. So the entire distance is going to be 26. And we're just solving for x. So we're done. I want to show you what we're actually doing. You're going to have a couple of these in your homework. Just be ready for them. I think you have a couple of these extremely easy ones in your homework as well. Once again, use theorem number 1. It's a right angle Pythagorean theorem. This is just really good review. It's really not that hard of a lesson today, I don't think. And then we get to this next theorem. And I'm saying that dramatically, like this is going to completely shatter this lesson. It's really not. This next theorem, I have a special name for it. It's called the party hat theorem. If you remember my traumatic story a couple weeks ago when we were still in school, I told you the story when I was in 7th grade and I had a party hat. The the string snapped me across my corneas, and my mom had to rush me to a optometrist in the city next to ours, and had my eyes dilated with this magical liquid. It was really crazy. Anyways, you might remember that. Here's the party hat theorem, folks. Draw yourself a circle. Give it a center. Let's call it D. And let's do this. Let's do this. I'm going to do a radius going up this way, and a radius going down this way. See if I can do this right. I always kind of struggle with this one. I'd like you to make a tangent line at, I should label these. What am I doing? Let's call this A. Call this C. And let's make a tangent line. So when you make a tangent line, your tangent line has to be perpendicular with this radius. You have to have and see a right angle right here. A lot of kids look at this and they say, "Oh, there's your tangent line." Sure, it looks like it's gonna hit right there, but does that really look like a right angle? Oh no. So a true tangent line is gonna look like a right angle, and I'm happy with how this looks. So go ahead and extend that. You know that's a right angle from theorem number 1, piece of cake. Let's do the same thing for this line right here. Actually, I think I need to make this a little longer. Okay. Find that right angle. Happy with that. Perfect. Once again, theorem number 1 says that's a right angle. And let's call this point way out here B. So you've got A, B, C, and then circle D. Now the reason why I call it the party hat theorem is, well, do you see the party hat? I see the party hat. There's the dude wearing the party hat. I don't know what this represents. Maybe that strap. Maybe it's going to snap him in his eyeballs. But you've got the party hat right there. That's why I call it the party hat theorem. Basically, here's what it says. If, do we do it? Yeah, let's do an if then. If then. If AB and CB are tangent to circle D, which it appears to be that they are. If AB and CB are tangent to the same circle, let me highlight them. If that is tangent to circle D, and this is tangent to circle D, then if they're both tangent to the exact same circle, then they have to be congruent. That's the party hat theorem, folks. Party hat theorem says that these two pieces, these two tangents are exactly the same. They even look the same. Then AB is congruent to CB. Alright, party hat theorem. That's the last theorem. I got one more example and then we're calling it quits. Example 3. I'd like you to draw a circle. Give it a center. Call it center T. And see if we can do this. Let's start off with a tangent point right above, but we're not going to connect these 2 points. Call this N. And I want a horizontal tangent line. Let's do that. I'm not going to have it extend forever. I do want it to stop because what I want to do next is I want to take this point over here, and it could be a little different from yours, that's fine. But I want to connect that point. I want to swing the straight edge to make another tangent to the circle. About right, ding, there. You know, it looks like it's going to hit right there. So let's extend it. Let's call this tangent, point of tangent C. Let's call that M. Let's call this S right there. And then what you're going to need to do is I want to finish this. I want you to bring your straight edge. I mean, you can rotate it and swing it any way you want, but I want one more tangent line connecting these 2 line segments here. So I'm going to use this one right here. You kind of see I made a triangle. I made a circle inside a triangle. The circle is inscribed in the triangle. There's your point of tangency. Let's call it L. Alright, we're going to put Q up here. Let's put this point R down here. And I'm going to give you a whole bunch of distances. Everybody, I'm going to give you a whole bunch of distances. I'm going to tell you that from S to M is 10 centimeters. N to Q, I'm going to tell you, is 2 centimeters. Now, it's not drawn to scale. This obviously does not look like 2 compared to that 10, but just let's go with it, folks. I'm going to tell you that this entire distance from Q to R is 8 centimeters. Once again, does not look like 8. This is obviously longer than the 10, but we're just going to go with it. Alright. I would like you to find the perimeter of triangle SQR. Find the perimeter of triangle SQR. So, find that side distance, add it to that side distance, add it to that side distance. Perimeter is add up all the sides. Add up all the sides. Alright, how would you do a problem like this? How would you do a problem like this? I don't know. I don't know. Well, there's got to be a reason I gave you the party hat theorem on the very last page. Let's kind of turn this paper a little bit. Do you see the party hat right there? You see the hat sitting on this person's head? I see the party hat. Party hat theorem says if these two lines are tangent to the circle, which they appear to be, they have to be the same. If that's 10 centimeters, that's 10 centimeters. We got something. Okay, so if we could, let's see, what do we got? I know from S to Q, because if that's 10 and that's 2, that whole distance has to be 12. So this is 12 centimeters. And if this is, okay, so wait, if this is 10, is that 10? No. If this is 2, it's, oh, okay, we got another party hat right here. Take a look. Take a look. Tangent line. These two have to be the same. That's 2 centimeters. And this is where a lot of kids say, I don't know why they do this. They say, is that 2 centimeters? Is that 2? No! This whole distance is 8. And if this is 8 and that's 2, subtract. Wow. I just gave you the answer. Not that you couldn't do that all by yourself. Take the total distance, subtract that partial distance, and you should be left with 6. This is 6, which means, and that's another party hat theorem. Flip this around if you need to. You got a party hat upside down, which means these two are exactly the same. So if that's 6, that's 6. We've got a distance of 12 on the top. That's a distance of 16. Let me write this down. The perimeter is 12 plus 16 plus this total distance is, well, they gave you that, 8. Add this all together. The perimeter is, let's see, that's 20. 20 plus 16 is 36. Perimeter is 36 centimeters. Party hat theorem, folks. Just use the party hat theorem. Your homework. It's on page 737. And I'm looking at problems 17 to 22, 24, 25, and 44 to 46. Once again, send me your homework. Gotta have your homework before midnight tonight. And do me a favor, everybody. Get yourselves outside. Enjoy some of this amazing weather outside. And you know, keep doing your homework. If you got questions on your homework, feel free to shoot me an email, and I'll get back to you. I'll try to get back to you as quickly as I can. And we'll go from there. Have a great Wednesday. We'll see you Friday, folks.